Okay, so I'm gonna skip a little bit of step. We just now in the previous videos we saw how we derived the sum of product roots for quadratic equations. Then we look at how we derive the sum of product roots for cubic equations. All right. For quartic, you girls can do exactly the same thing, and you're gonna end up with this. All right. You're gonna end up with this these four things. Now, the stuff that is boxed in red is actually on your reference sheet, so you do not need to memorize it. And good thing about this is if you see a pattern, if you notice a pattern, it's very easy to remember the quartic, even though it looks very complicated. All right, so if you look at a quadratic, some of the roots, well, quadratic, obviously you will maximum only have two roots. So sum of roots is negative b on a, and product of roots is c on a. For cubic, you can have three roots. Sum of the single roots is negative b on a. If we look at the pairs of roots, you're going to get a c on a. And then if the product of roots, so three pairs all together, is going to get negative d on a. So notice the pattern, negative b on a, c on a. Over here is negative b on a, c on a, negative d on a. For quartic equation, you are going to have four roots, all right? So if I add them, all the single roots added together, you're going to get negative b on a. If I group the two pairs of roots together, I'm going to get 6 different combinations, okay? So all of them added together, the sum of the pairs of roots is going to give you c on a. If I group 3 of these together, okay, 3 of the roots together, I'm going to get 4 different combinations, 1, 2, 3, 4. If I add all of them, so the sum of 3 triple roots, okay, sum of the triple roots is going to give you negative d on a. And finally, if I multiply all 4 roots together, I'm going to get e on a. Notice the pattern that generated from here. Okay, so over here is negative b on a, c on a, negative b on a, c on a, negative d on a. Over here is negative b on a, c on a, negative d on a, e on a. Alright, so you can see a pattern, so it's easily you can easily remember this without a derivation process. Let's actually use this to solve one of the questions that you may encounter. Alright, so for example, if I have alpha, beta, and gamma, if I say let alpha, beta, and gamma be the roots of a third-degree polynomial, and that's just a random polynomial, okay? We want you to find the value of this thing. It looks a bit complicated, but I can see this cubic, so I'm looking at the red box over here. I've got alpha, beta, and gamma, and I need this. So in another word, this is my starting point. That end point is my starting point. I want to look at this and I say, well, can I rewrite this fraction? Okay, this is where algebra has been quite strong. You look at this and say, can I rearrange this fraction to something like that? So I'm going to start with that. So I say 1 on alpha beta plus 1 on alpha gamma plus 1 on beta gamma. Can I rewrite it in one of the forms that is in the reference sheet? All right. So I see they are fractions, so obviously I need to deal with common denominator. By looking at it, I'm going to look at, well, actually I can multiply all 3 of them together. Okay, so the first one would be alpha beta, so I have gamma plus, this one is alpha gamma, so this is beta plus beta gamma, so I'm missing alpha. And suddenly, if you look at this, isn't this just this? And isn't this just this? So great. So now in your head you go like, okay, I know what to do now. I first need to know what is the sum of product. Okay, in this case, it is negative b on a. Negative b is negative 4, which is 4 on 2. Okay, so we've got 4 on 2, which is 2. Now I've got alpha, beta, and gamma. I wrote alpha again. Okay, alpha, beta, gamma is negative d on a. What is d? D is the last one. Okay, this one. So it's 4 on 2, but it's negative, so it's negative 4 on 2, which is negative 2. Okay, so I've got these two. Take this, substitute in where it should go to. Take this, substitute it into wherever it should go to. Therefore, 1 on alpha beta plus 1 on alpha gamma plus 1 on beta gamma is equals to 2 over negative 2, which is just negative 1. That's the end of this question.